So in the board, you can see that we have two right angle triangles. Now, why are we calling them right angle triangle? As we know that in a right angle triangle, at least one angle will be 90 degree. So you can see that in both these triangles, we have angle ABC, which is 90 degree or a right angle. So obviously, both of them are right angle triangle. Now, in a right angle triangle, when you talk about the sides, we have three sides here, AC, BC, and AB. We can divide them in three things. One of them is, we are going to call it hypotenuse. The other one is adjacent. The other one is opposite. It's very important to understand which one is what. First of all, let's talk about the hypotenuse. Okay, so the biggest side of the right angle triangle is the hypotenuse, and we can clearly see that AC is the biggest side of these two triangles. So for both of them, AC will be the hypotenuse. Remember, the biggest side is the hypotenuse. So both of them, AC is the hypotenuse. Now, about adjacent and opposite. Adjacent and opposite is not fixed. We cannot say that this one is the adjacent or this one is always the opposite. You can't say that. It depends on the angle. So let's see, we have this angle here. So angle ACB. So what do we know about angles? When two sides meet, they create an angle, right? Which sides are creating this angle? One is AC, the other one is BC. So AC and BC are meeting and they are creating this angle. AC is already the hypotenuse, and the other side that is creating the angle is the adjacent. So which is the adjacent here? BC. The adjacent here is BC, right? But let's talk about this angle. Now we have the angle BAC. Now who's creating that angle? One of them is AC, the other side meeting here and creating the angle is AB. So for this triangle angle, when we are considering angle BAC, BC is not the adjacent anymore, because AB is actually creating the angle with AC. So AB will be our adjacent. And when you have found the adjacent, automatically the other side becomes the opposite. So which one is the other side here? BC is the adjacent, the other side is AB. So AB is opposite here. And for this triangle, BC is the other side. So BC is the opposite here. So what we learned from here is the biggest side of a right angle triangle is the hypotenuse, and whichever the other side that is creating the angle with the hypotenuse is adjacent, and whenever you have found the adjacent, the other one automatically becomes the opposite. I guess the sides and their names are fixed now. We can find them easily. Now let's see how this information can connect us to trigonometry. Let's go to Pythagoras theorem. Now let me ask you a question. How do you find the area of a square? Let's see this one. So this, let's say this is square which has side 3, and we know that in a square all the sides are equal, right? So if this is 3, this is also 3, this is also 3, and this is also 3. How can we find the area of the square? We simply, what we have to do is square one of the side, because all the sides are equal, and we will have our area, right? If it's centimeter, then it will be centimeter square, right? So the area of this square is 9 centimeter square. Okay, now let's say we have a triangle, right angle triangle ABC. Now let's say we have another square whose sides are AC. That means this is AC, this is AC, this is AC, and this is AC. All of them are AC. Now just like this one, if I want to find the area of this square, what will it be? It will be AC square, right? We could do this, 3 square equals to 9, but AC we don't know what it is, so we are just writing it AC square, right? Now let's say we have another square whose sides are BC. So all the sides are BC. How do you find the square of this area of this square? Just square it, right? BC square. Now let's say we have another square, the side of which is equal to AB. So all the sides are AB. So what will be the area of the square? AB square, right? AB square. Now what Pythagoras theorem tells us is, if we add the area of this one and this one, if we add the area of this one and this one, that means AB square and BC square, it will be equal to the area of this one, that means AC square. So simply what it means is, if you have a square on your hypotenuse, the area of the square will be equal to the area drawn with the other side square, right? With a square on BC and with a square on AB. So the area of BC square and AB square, if you add them, it will be equal to the area drawn on our hypotenuse, which is AC square. So simply you can put it like this: for this triangle, AC square equals to BC square plus AB square. Now, one thing is to be noticed here, that there are no angles, right? So if there are no angles, we don't need to be confused about which one is opposite and which one is adjacent. Pretty simple. Hypotenuse square equals to adjacent square plus opposite square, and any one of them can be taken as adjacent and opposite, as we do not have any angles. I hope the Pythagoras theorem is clear to you. Now when you solve some maths, it will be more clear. Now let's solve some maths. So this is our math number 1, where we have a right angle triangle, and in this right angle triangle, this angle is 90 degree. What we are given is side BC, the length is 3 centimeter, and side AB, the length is 4 centimeter. And we are asked to find the length of AC. Now, what do we know from the Pythagoras theorem? That hypotenuse square, that means AC square, will be equal to BC square plus AB square, right? So AB square. Now we have basically all the values. We don't have AC square. Let's put it like this: AC square. We have BC, which is 3, so square on 3, and then we have AB, which is 4, so square on 4. Then we have AC square equals 9 plus 16, right? So then if you find AC square, it is equals to 25. If you want to remove that square, we need to root over both sides, right? Let's root over it. AC square equals root over 25. So it removes the square, the root over, and root over 25 is 5. So it's 5 centimeters. See, just using the Pythagoras theorem, we very clearly found that AC will be 5 centimeter. Okay, so it was very straight cut. Let's see another one, just to be clear. So this is our math number 2, where we have xy given, which is 7 centimeter, and zy given 4 centimeter, and we are asked to find the length of xz. Now what do we know from the Pythagoras theorem? That the square on the hypotenuse, which is xy square, will be equal to the square on zy square, that means other two sides sum, right? So xz square. So square on the hypotenuse equals to square on opposite and square on adjacent, right? Summation of that one. So let's see the information. So we have xy, that means this one is given. So it is 7 square equals to zy, which is 4. So 4 square plus xz square, we don't have it, we are asked to find it. So 7 square is 49 and 4 square is 16 plus xz square. When you bring that 16 to the other side, it's going to be 49 minus 16 equals to xz square, right? So we have, let's just switch sides to make it better. So xz square equals to 33. If we root over them, then we are going to get xz equals, if you root over 33, you are going to get around 5.75 centimeter. So using that thing, now we have the hypotenuse and let's say adjacent. Now we also found the length of the opposite, which is 5.75 centimeters. So 5.75 centimeter, right? Just like this one, you can use the Pythagoras theorem, and if two sides are given, you can easily find the other side. Now that Pythagoras theorem is done, I think it's pretty clear to you. Let's see how we can use the right angle triangle with some trigonometric functions to calculate some more things. Let's go. So let's talk about an analogy first. First of all, let's say you have some fruits, but you don't want to eat them as a whole. You want to drink some juice, right? So what you need to do is put the fruits in a juicer, and the juicer will convert the fruits into juice, right? So what is this juicer here? It's a machine. What the juicer is doing is converting the fruits to juice, right? Why? Because you don't want it to eat some fruits, you want some juice to drink, right? Okay, now what I said earlier, that we can use trigonometry to calculate very easily to find the lengths of very tall and long things, right? So how do you do that? We use the angle, but angles directly cannot be used to find the lengths of anything. We cannot directly use the lengths. What we need to do is convert this angle to values. How do you do that? Just like the juicer, we need some machines. So what I'm going to do, we need angles to be converted to values, the values that we can use actually to find lengths of different things. So here we need a machine, just like the juicer we need a machine. Those machines are called functions, and as we are learning trigonometry, those machines will be called trigonometric functions, right? So trigonometric functions. Okay, let's say this one. So what the trigonometric functions actually do, they take the angles and convert them to values, and those values can be used to find lengths of different sides or the other things. Okay, now in trigonometry, we basically here we are going to talk about three kinds of functions, three kinds of machines, right? First of all, the first function is called the sine function, and in the short form we are going to use sin, sine. Okay, it's not sin, it's sine. Okay, now number two, we are going to use another machine, another function called cosine, and in short form we are going to call it cos. And as three, we are going to use another one, tangent. The function is called tangent, and in short we're going to call it tan. So we can use the sine, cos and tan function to turn angles into values, and then use those values to calculate the lengths of sides. Let's see how we can do that and what this function actually means. So here you can see that I have replaced the 40 degree with, this is called theta, it's a symbol. The theta just represents angle, right? So let's see what these functions actually tell us. Okay, first of all, if I put the angle inside the machine, that means the sine theta, the sine function, it tells us a ratio, where ratio is between the opposite and the hypotenuse. And as we talked about earlier, AB is creating the angle, so AB is adjacent. That means AC is our opposite. So what the sine theta tells us is opposite divided by hypotenuse. Okay, these are the short forms. So opposite divided by hypotenuse. For this triangle, we can say that when we say sine theta, it's equals to opposite, which is AC, divided by our hypotenuse, which in this case is BC. So sine function represents the ratio between the lengths of opposite and hypotenuse. That's it. Now one thing to mention here is that as the juicer, if there are no fruits inside the juicer, the juice cannot be delivered. Just like this thing, you cannot just write the function, you must give an angle to the function, right? So see, this angle has been given to the sine, and only then it is giving the ratio. So remember, not only sine, we have to give sine and then some angle. Okay, now let's talk about the cos theta. Cos, let's say the cos function, we gave him the angle. Now what the cos is going to do, it is also going to give us a ratio, and the ratio is between the adjacent and the opposite. So AB is adjacent, obviously, so we have adjacent and divided by hypotenuse. Okay, so what we're getting here is AB divided by BC. Okay, now we are left with one more function, which is tan. If I give the angle to the tan function, it's going to represent us with the ratio of opposite and the adjacent. It has nothing to do with the hypotenuse. It will give us the ratio of opposite and the adjacent. So basically opposite divided by adjacent. So we are going to get, what we're going to get is from here is AC divided by AB. So that is it. So small recap, that our sine, cos and tan function, when given the angle, they represent ratios. Sine function represents the ratio of the length of opposite and hypotenuse, which is in this case AC divided by BC. Cos function, when given the angle, represent the ratio between the length of adjacent and hypotenuse, which in this case is AB divided by BC. And tan angle, the only function tan that do not represent the hypotenuse, it represents the opposite divided by adjacent ratio, which is in this case AC divided by AB. Now let's see how we can use these functions and these ratios into our maths. So for our first math, we have this figure and we are asked two questions here. First of all, find the length of AB, and then B, find the length of BC. Now we can see the angle. First of all, let's determine which one is our adjacent and which one is our opposite. First of all, obviously hypotenuse is always with the angle, which is AC, and which one is with our angle? BC, right? BC is making the angle with the hypotenuse. So BC is adjacent and AB is the opposite. Now, first of all, we are asked to find the length of the opposite, which is AB. Now, what do we know that represents opposite and our given length, which is hypotenuse? We have to use the information that has been given to us, right? First of all, we have been given the information about the length of hypotenuse and the angle, and we have been asked to find the length of the opposite, right? So opposite hypotenuse angle, what is that? We know that sine theta represents this thing, sine. Now we are not going to write theta because theta was just a symbol that was representing our angle. We have been given the angle, which is 45 degree, right? So sine 45 degree equals to, what do we know about sine? What ratio sine represents? It represents the opposite divided by hypotenuse, which is AC, right? AC. Okay, so this is the thing we can write from the information given to us. Now the value of sine 45, if you put it in your calculator, you're going to get a value which is 0.707. Okay, equals, you have AB, we don't have AB. We are asked to find AB. So what is the value of AC given? 6. So we want to find the value of AB. So 6 comes to the left side and it will be multiplied. So 707 multiplied with 6 equals to AB. Let's just switch things. So AB equals, we'll have something like 4.54 or something like that. Okay. So see, if it's centimeter, the answer is centimeter. Just like using the sine function, we pretty easily calculated AB, right? So just like that, using the function and the ratio, you can use hypotenuse and opposite and the angle to calculate the side, another side, okay, whichever side you want. Okay, now let's solve number B and see how we can actually use the function to solve it. Now let's move on to our question B. Now for B, I have changed the values a little bit, but it's okay. We're going to follow the same things, right? So for B, what informations have we been asked? The BC. Now what is BC? Opposite or adjacent? See, BC is creating the angle with the hypotenuse. So BC is actually adjacent. We have been given the information about hypotenuse and we have the angle. Now what function can we use for hypotenuse, adjacent and angle? Yes, cos. So we can use cos, and in place of theta we have the value, so we are going to use cos 60 degree, and we know that cos gives us the ratio of adjacent and the hypotenuse. Adjacent we don't know, which is BC. Hypotenuse we know, which is 5. So again, if you put cos 60 in your calculator, we're going to get a value. The value is 0.5, and then you will get your 5 to the other side, it will be multiplied, right? So you have BC. Let's just switch the sides. We have BC equals, multiply them, you're going to get 2.5 centimeters. So just like using the cos function, we can calculate the adjacent pretty easily. So now BC is 2.5 centimeter. Okay, now let's see how we can use the tan function. So for our next question, we have been given a triangle PQR. So PQ is the hypotenuse as we can see it, and PR is making the angle with PQ, right? So PR is our adjacent and RQ is given 8 centimeter, and this is obviously our opposite. PR is the adjacent, that's the thing to be noticed, because PR is creating angle with PQ. Now the informations given to us is the opposite, and we have been asked to find the adjacent, and we are also given the angle. Now what function comes with angle, opposite and adjacent? No hypotenuse. Yes, tan function, right? So we can use tan 30. We are not going to use theta because the value of theta is given, equals to, what do we have here? We have opposite divided by adjacent, right? Which one is opposite? 8 is opposite. That means QR. Adjacent is PR. We don't know it. We're asked to find it. So if you put it in a calculator, you'll get a value of 0.577 equals 8 divided by PR. Now that you want to calculate PR, you have to get the PR to the left side. So it will be multiplied as it was divided with the 8. So multiplied by PR equals to 8. Now you want to calculate PR, so you have to move 0.577 to the right side. So you have PR equals 8 divide 0.577. Now if we use the calculator to calculate the value, you will get a value like PR equals to 13 point something. You will have something values here. So centimeter. So just like that, using the tan function, you can also calculate the length of the opposite or the adjacent depending on what you need, using the tan function and the angle, right? Okay. So we have seen how sine, cos, and tan can be used to find lengths of different sides. But can we actually calculate the measurement of angle using the sides and the functions? Let's see how we can calculate angles from our next math. So for our next math, we have another triangle BAC. We have the length of the hypotenuse 7 centimeter, and we have the opposite. This is opposite because it doesn't have any angle. This has the angle, so AC is the adjacent, right? So BC is given, that means our opposite is given, our hypotenuse is also given. We are asked to find the angle theta. So find angle BAC. We have to find the measurement of theta, right? Now again, let's see what we have been given. We have been given the hypotenuse, the opposite, and the angle. What function can we use? We can use sine function, right? Because sine function gives us the ratio between opposite and the hypotenuse, right? So now we don't have theta. That's what we are asked to calculate, theta, right? So sine function equals opposite divided by hypotenuse. That's what we wrote. Now we have to find the value of theta. Let's see how we can do that. So sine theta equals, if you put it in a calculator, you're going to get a result like 0.71. Okay, now when you want to calculate the angle from this thing, you need to move the sine to the other side. So when you move the function to the other side, it's going to get inverse. Like sine will become sine inverse 1. Okay, and this thing is also in your calculator. Now what if it was tan? It would be tan inverse 1. What if it was cos? It would be cos inverse 1. So whatever function it has, now it's going to be inverse, right? Now then you have 0.71. Remember to put this value inside the bracket in your calculator, right? When you calculate it, you just put sine inverse 1. It is in your calculator. Bring sine inverse 1 and then put the value, close the bracket, and push enter. You're going to get a value. For this one, you're going to get a value of 45.58 degree. This is an angle, so we are just putting the unit there, which is degree. Just like that, also using the function, you can also calculate not only the length but also the measurement of angle, right? Okay, so that is it for today. We actually learned everything about the right angle triangle using trigonometry. We understood which side is called what, hypotenuse, adjacent, and opposite. We then understood what Pythagoras theorem is and how it works. We saw some maths, and also then we saw some functions. So we understood function and how functions actually work for right angle triangles in trigonometry. So I guess if you have watched the full video, you should not have any more confusion about right angle triangle and trigonometry. In our next video, we're going to cover the remaining part. That means how we can use this function also for not right angle triangles, other triangles that are not right angle, right? So until then, this is for today. See you in our next video. Thank you for watching.